All right, welcome. Today we are jumping headfirst into the world of artificial intelligence to really demystify SARSA. It's a super important algorithm in reinforcement learning that basically teaches machines how to learn from trial and error.
Okay, so here's our game plan. First, we're going to break down what that weird name, SARSA, even means. Then we'll walk through how it actually learns. After that, and this is the big one, we'll get into the whole on-policy versus off-policy thing. Then we'll put SARSA in the ring with its famous cousin, Q-learning, and finally, we'll talk about why any of this actually matters in the real world.
All right, first things first. What in the world is SARSICA? Let's decode that name and get right to the heart of what this thing is all about.
So the name isn't just some random letters thrown together. It's literally the recipe for how the algorithm works. It's a 5-part snippet of experience. You have the current state you're in, the action you take, the reward you get for that action, the new state you find yourself in, and, crucially, the next action you plan to take from that new state. That whole sequence, state, action, reward, state, action, SARSA, that's the magic ingredient it learns from. So what makes SARSA tick? Well, a few key things. It's a cornerstone of reinforcement learning, and yeah, it's a lot like Q-learning, which you've probably heard of. Its whole goal is to figure out the best strategy, or what we call an optimal policy. But here's the most important part. It's a model-free algorithm. What that means is it doesn't need a map of the world beforehand. It just gets thrown in and learns as it goes, figuring things out purely through experience.
So how does an agent actually do that? How does it go from being completely clueless to figuring out a smart strategy? Let's pop the hood and take a look at the learning process step by step.
It's really just a continuous loop. First, you set up this giant cheat sheet called a Q table, which is just a big grid of guesses for how good any action is from any state. Then the agent starts moving around, and it has to balance exploring new moves it's never tried with exploiting moves it already knows are pretty good. Every single time it moves, it grabs that 5-part SARSA experience and uses it to update its cheat sheet, making its guesses just a little bit better. And then it just does that again and again and again, getting smarter with every single cycle.
And at the absolute core of that learning loop is this update formula. Now, it might look a little intimidating, but let's break it down. All we're doing is figuring out a new, better value for being in a state and taking an action. We take the old value, and then we add a little adjustment. That adjustment is controlled by 2 main knobs. You've got alpha, the learning rate, which is kind of like how much you trust new information. And then you have gamma, the discount factor, which decides how much you care about rewards right now versus rewards way off in the future. This little equation, that's the engine that powers the whole learning process.
Okay, now we are getting to the single most important concept that defines SARSA. This is what really makes it different, what gives it its unique personality compared to other algorithms.
And here it is. This is the whole ballgame. SARSA is on policy. What that means is that it learns from the consequences of the actions it actually takes while it's exploring. It learns how to get better at the game it's actually playing, including all its random moves and mistakes. It learns from its own behavior.
I love this analogy. Think of an on-policy agent like SARSA as someone learning to walk a tightrope. It pays really close attention to its own wobbles, its own missteps to get better. An off-policy agent, like Q-learning, that's like learning by watching a video of a world-class acrobat. It tries to learn that perfect, flawless policy, even if its own steps are still really clumsy and all over the place.
So, with that huge distinction between on-policy and off-policy in our heads, let's put SARSA and Q-learning in a head-to-head matchup and see exactly how this difference plays out.
And this visual just says it all. Check out the SARSA diagram on the left. You see that arrow pointing to 8'? That's the key. The update depends on the specific next action the agent actually decides to take. Now, look over at Q-learning on the right. It doesn't care what action is actually taken. Instead, it looks at all the possible next moves and bases its update on the best one, the one with the maximum value, the perfect theoretical move.
And when you look at the formulas, it's even more obvious. See that little max operator in the Q-learning equation? That's the dead giveaway. It's an optimist. It always assumes the absolute best action will be taken next, which we call a greedy policy. SARSA, on the other hand, just uses the value of whatever action it actually decided on next. Its target policy is the exact same as its behavior policy.
So let's just boil it all down right here. Q-learning is your off-policy optimist. It's learning the perfect, ideal path, completely ignoring any potential mistakes from exploration. SARSA is your on-policy realist. It learns the best path given that its own strategy involves a bit of randomness.
It has to account for its own behavior.
Okay, so an optimist versus a realist. Why should you care? Well, it turns out that this seemingly small philosophical difference has massive, massive consequences for how these algorithms behave in the real world.
And this is really where the rubber meets the road, because SARSA learns from its own real-world behavior, including all its fumbles during exploration. It tends to learn a more conservative, cautious policy. And that caution is incredibly valuable in situations where making a mistake is really, really costly. Like with a physical robot, you'd probably rather it learn a safe and reliable route than a theoretically faster one that involves walking right along the edge of a cliff.
So here's the bottom line. Q-learning can learn a perfect, optimal policy that might only be safe if you follow it flawlessly. But SARSA learns a policy that is still safe even when the agent goes off script and explores. It learns the best way to get things done while fully acknowledging its own imperfections.
And that really leaves us with one final thought to let this all sink in. When the stakes are high, like with a self-driving car, understanding the difference between a greedy optimist and a cautious realist isn't just some academic exercise, it's everything. It really makes you ask, what kind of intelligence are we actually trying to build?